We're looking at B2 Part D on the 2012 paper, where we have a point M, 1, 2, 0, and we have it going through a point on the line D1 and a point on the line D2. Now, the way I'm going to have a look at it is that the plane alpha contains both the line D1 and the point M, and the plane beta contains both the line D2 and the point M. So what I will do is I need to find, now let's say the point on D1 is capital D, and I would cross that because this is the plane alpha, how I get the normal to plane alpha with the direction vector of D1. So the point D1M is equal to, now I do 1 minus 7, 2 minus negative 14, and 0 minus 0, which is equal to 8, 16, 0. We can do this because we know that the plane alpha contains all of D1, and we know that a point in D1 is minus 7, minus 14, 0. This here can therefore be simplified to 8 times 1, 2, 0. Now we know the direction vector. We know the direction vector of 1 is, from above, is 2, 3, 1. So if I dot these two, if I cross these two vectors, and even simplify them and simplify them down, I'm going to get 2 minus 1 minus 1. So we know that this is the normal of plane alpha. I now do the same. I'm going to do exactly the same for the plane beta. So if I just make sure that's all for alpha. So plane beta, well, that's going to be a point on the line, we'll call that D2 to M, cross with the direction vector of D2. And therefore, we need to find D2 to M, which is simply just looking at doing, find what M is. So it's going to be 1 minus 10, and then I'm going to do, it's 2 minus 6, and finally 0 minus 0, which is equal to 11, 8, and 0. So I know that D2 is 3, 2, 1, so I'll just quickly just cross them, and we get the normal, which is 8, 11, minus 2, and this is the normal of plane beta. So what I can do is, if I do 8, 11, minus 2 and cross it with 2 minus 1 minus 1, I'm going to get the vector that contains the line that I want, L, the direction vector of L. So that's going to be 9, 4, 14. And that contains, that's the direction of L. Because I'm doing a perpendicular and perpendicular, so I'm going to get to what I wanted before, what I want. So what I have is L is a vector in parametric form. X is equal to, we just take a point on the line, which is 1, 2, 0 from M. So it's 1 plus, and I'm going to use t as my parameter, 1 plus 9t. Y is equal to 2 plus 4t. And z is equal to simply just 14t. And if you want to say that t is a set of real numbers. And that's hopefully helps you with how to do that. I understood that you, in class, you're looking about it a slightly different way. I'd be interested to know what your final answers were, if they're the same. Obviously, you can choose different position vectors. The position vector 1, 2, 0 is taken from the point M.